first meeting with my store manager. And you were so red.
Okay, for Christmas,
Is
I
it
showed
ball
them
cap?
the bread.
I had to.
Me, so I'm just started crying hysterically.
It was so hard to get it on.
Can you breathe like
No, it did not come up all the way. I was blue for a day. Oh. And I
Okay,
was scrubbing.
here's today's participation sheet.
You wanna see my shirt costume?
What? It's nice.
I wish I was Shrek today.
Okay, so this is what we're gonna do today. I'm gonna introduce you to a new set of rules that allow us to do problems in section 5.4, okay? And there's a fundamental difference between the rules that I'm gonna introduce today and the ones that you're already familiar with. So I'll need to explain these rules and the fundamental difference. And then we'll start working some problems in these rules. And the way it goes is next week, a quiz should be made available to that Sunday night. And then we come back and we do it, and we have another week, and then you get the test. Does everybody understand that? Okay, so we still have time to continue working on these problems. So the problems you should be working on are the problems in 5.2 and 5.4. Okay? All right, so the rules that you've had up until now are called the rules of inference, okay? The rules of inference. And it's something like this. From X, we may deduce Y. Okay, so for example, if P, then Q, P, therefore Q. Okay, and this is from these things we can deduce this thing. Okay, so we're, as it were, making a new claim based on existing claims. Does everybody understand that? I like them already. Okay, the rules that we're about to encounter now are called the rules of replacement. Okay, and basically what we're saying is this thing is the same thing as Y. So wherever you have this, you may replace it by that or vice versa. Okay? So that's the first difference, and I'll talk about more in a minute, okay? But the first rule I would like to introduce you to is called De Morgan's. Okay? And so it involves negated conjunctions, and it also involves negated disjunctions. Okay, remember early on when we had a statement of this form, you wanted to push that negation through, right? And I said you can, but not in the way you think you can. And so if you have something of this form, you may push that negation through, and what you get is, and I'm going to use our special notation, the opposite of the box, and then and changes to an or. That's the thing that you guys were not really aware of, and then the negation of the circle, okay? So if I have this, I can switch it to that, and I can go the other way around, okay? So suppose I have this, not P and not Q. So if I'm going to push this negation through, because this is a negated conjunction, the P would become a not P, the and becomes an or, and the not Q would become a Q. Does everybody understand that? And also know this, that if we had this, we could, in some sense, pull a negation out and go back to this. Does everybody understand? So if you have something of this form, you can go to that. If you have something of that form, you can go back to that, all by the rule De Morgan's, okay? And now, our first example was a negated conjunction, but you can also apply De Morgan's to negated disjunctions, okay? And so you push the negation through, so we get the opposite of whatever the box was, and the or changes to an and we get the opposite of whatever the circle was. And there you go, okay? And you can go from this to that, or that to this, okay? And remember that these are variables. My examples I've always been using like individual statement constants as substitution instances of these, but consider the following. Suppose I have not S or B if and only if G, okay? This is a big negated disjunction. Everybody see that? So if I follow the rule, I push the negation through, not T would become T, or becomes and then I would get the opposite of this thing, not B if and only if G. Does everybody understand that? So don't think that these have to have a one-to-one correspondence with a single statement constant. It's anything. Does everybody understand that? Okay. All right, so that is De Morgan's. Okay. Next up is commutivity. Okay. You might remember this. We had the rule simplification, which is if I have this, box and circle, I can deduce box. That was my simplification. And you said, doesn't circle follow? And I said, yes, it does follow, but it's not allowed by our rule. Our rule of simplification says we are allowed to get the left conjunct and only the left conjunct. And that seemed crappy because we know if we have a burger and fries, we have a burger, and we also know we have fries, okay? Well, com lets us fix this. So if we have a box and a circle, we may replace that by circle and the box, and now if we wanted to get the circle, we could simplify. Does everybody understand that? So, and this is by com, and so if you have this, you can switch it back to that, okay? And com can be done on conjunctions, and com can be done on, did I say conjunctions, and it can be done on disjunctions, okay? So you can flip them, but only for ands statements and only for or statements. Don't do some flipping on me with conditionals. Does everybody understand that? This only applies to ands and ors. All right. Associativity. Box and circle and triangle. Okay. Now notice that this statement, the operators are all conjunctions. Okay. So notice that they are all conjunctions, and this circle is associated with the triangle because it's bracketed with it, right? Yeah, this is associativity, okay? So what I can do is I can change the brackets. I can move the brackets and associate the circle with the square. So if I had this, I could replace it by box and circle and triangle. So all I did is I moved the brackets over. Does everybody understand that? That's all I did. Why might this be important? Well, suppose that I have this mess and I want the triangle. Well, the first thing I might do is associativity to isolate the triangle. then I might do a COM and put the triangle on the left-hand side, and then I could do a simplification and get the triangle by itself. Does everybody understand that? Okay. All right. So we can do it when we have a string of conjunctions. We can also do it when we have a string of disjunctions. Okay. So I could end up with box or circle or triangle. Everybody get that? So notice it's all ands or it's all ors. Okay, we can't do it for mixed stuff. Okay. We have another rule called distribution. So suppose, and now this one has a mix of ands and ors. Box, and, circle, or, triangle, okay? We can replace that with an equivalent statement, okay? Now let's think about what this might be saying so that we can understand its equivalence. Suppose this says something like, I have a hamburger and fries or onion rings. That's the same as saying, I have either a hamburger and fries, or I have a hamburger and onion rings. Right? Okay. So if I have a statement in this form, I can convert it to a statement in that form, but I can also go, what? Back this way. And going back this way is often very helpful because I might need the box and it's stuck in that. But if I convert it to this, now I can simplify straight to that box, whatever that box might be. Okay. And we also have distribution going like this. Box, or, circle, and triangle. Okay? That can be converted into the following. We're distributing the box to the circle and to the